E equals mc² is a famous equation proposed by Albert Einstein in 1905. It establishes a direct relationship between mass and energy, stating that the energy in a system is equal to the mass multiplied by the speed of light squared. So, let's say we have a small object with a mass of 1 kilogram. To find the amount of energy this object contains, we can use the equation E equals mc², where c is the speed of light. E equals 1 kilogram, x, 3 by 10 carat 8 meters per second to E equals 9 by 10 16 joules. This calculation shows that a small amount of mass contains an enormous amount of energy. This concept forms the basis for nuclear energy, where the energy released from the splitting of atoms is converted into usable energy. For example, in a nuclear reactor, uranium atoms are split apart, releasing a tremendous amount of energy. The mass of the uranium before and after the reaction is slightly different, and this difference in mass is converted into energy according to E equals mc². The amount of energy released by nuclear reactions can be calculated using the equation E equals mc². For example, let's say that one uranium atom releases 200 million electron volts of energy when it undergoes fission. We can calculate the amount of energy released using the following equation: E equals m_f, m_I, xCa², where m_f is the mass of the uranium after fission, m_I is the mass of the uranium before fission, and c is the speed of light. The mass of the uranium atom before fission is 235.04 atomic mass units, AMU, while the masses of the two fission products are 98.91 AMU and 136.03 AMU. m_I equals 235.04 AMU. m_f equals 98.91 AMU plus 136.03 AMU equals 234.94 AMU. Using these values and the speed of light, we can calculate the energy released by the reaction. E equals 234.94 AMU 235.04 AMU, x, 3 by 10 carat 8 meters per second to E equals 1.49 by 10 carat minus 3 kilograms x, 3 by 10 carat 8 meters per second to E equals 1.34 by 10 17 joules or 200 MeV. This calculation shows that a small amount of uranium can release a tremendous amount of energy through nuclear reactions, thanks to the relationship between mass and energy described by E equals mc².